back, sports fans. Today I want to tell you about my solution for hanging a curtain or a closet rod inside the van. The first thing I decided is my basic design axiom for this project was whatever I designed, I wanted it to be as sturdy and as rigid as something that was built into the van. If you had bought it directly from Van Duit, you would expect something that was really high quality, that was rigid, that wasn't going to come loose, it wasn't going to rattle. And I knew right away that what I wanted to use was this stuff called architectural closet rod, or a heavy duty closet rod. This particular rod, it is always 1 5/16 inches in diameter. That's a builder standard. It's much larger than a typical closet rod, and it's much heavier as well. This is rated to support about 250 pounds over a 32-inch span. This span is longer than 32 inches. This is already cut to length for my application. We've done chin-ups on this rod with the clamps that I've designed. So I knew that I wanted to start with this rod, and I thought to myself, well, how will I attach this to the 80/20 rails that are already present in the van? And I realized that bicycle manufacturers have solved this problem a long time ago. It's called a handlebar stem. And handlebar stems undergo stresses, twisting stresses, that are orders of magnitude larger than what we're going to experience here. When you have a heavy rider and they're going down a rocky downhill and they may or may not have a front suspension. So here's an example of a piece of the rod mounted on a piece of 40/40. This was my first attempt at the clamp. I wanted to have that bicycle stem aesthetic. I rounded all the edges and I countersunk all the bolts. I wouldn't do it again. It's a huge amount of work. It doesn't work any better than the ugly, purely for function, not fashion look right here. In fact, I kind of like this better. It's a little shinier. In any event, this thing is mounted on some T-nuts, of course, so it can slide anywhere along the profile that you want. The bolts that hold this in place are completely hidden inside the clamp. As you can see, this was machined out of a single block of aluminum and then cut in half, because I decided that was the easiest way to make two pieces that would line up. Not only does the hole line up perfectly, but even the machining marks, even the striations that are created by the machining line up, which I find really nice. It's kind of like when the pattern on a shirt, on the two halves of the shirt, line up along the placket. That's a sign of a good tailor who knows what he's doing. So anyway, the bolts that hold this down to the rod are down to the profile are recessed. I use a flathead bolt which has a tapered head. The holes inside here are tapered to match the head, and then the T-nuts go on here. These T-nuts are the spring ball type, so they can be rolled into the 80/20 profile anywhere you like, and then you screw down your bolts. I deliberately chose these versus the turn-in style. I really dislike the turn-in style. It is possible through user error, ask me how I know this, to tighten them without actually getting them to engage fully, and then the result is whatever you tightened up will fall off while you're driving. In my case, it was a wall cabinet. So I vastly prefer these spring ball loaded T-nuts because they're much beefier, and once they're in place and they're screwed down, they are not coming out. Now, I've chosen a 5mm bolt for the clamp bolts, and there are 4 of them. I could have made a 2-bolt clamp, but I really wanted the extra strength of the 4 bolts. And I chose a 6mm to bolt the clamp to the rail. Now, why is that? Well, 8mm is the nominal preferred size to bolt into a piece of 40/40 profile, but there really wasn't enough room in here for a pair of 8mm flatheads. the head on a flathead is twice the diameter of the bolt itself. So that would have meant a pair of 16 millimeter flatheads in here, and they basically would have been touching in the center. As it turns out, it is fortunate that I want the rod to run perpendicular to the profile, because it means I can drill my 2 holes here and here, as opposed to, for example, here and here through the thinnest part of the clamp. I can drill through the much thicker parts of the clamp here and here in order to get the alignment that I want. Now, if you did want to mount something like that, I could make an adapter plate. So this is the completely assembled mechanism. This is the individual parts. I just want to point out also that I faced some challenges when I was machining these things, because my first clamp attempt was a pinch clamp. Think of a brake lever on a bicycle handlebar. A brake lever is a clamp. A brake lever clamp goes all the way around, almost in the 360, and then it has a single bolt that just pinches the 2 ends together. And what I did initially was I created a single bolt that went through one side of the hole, and I assumed that when I cut this in half that it would spread a little bit and the rod would go in. No such luck. The tooling I used to cut this hole is so precise, and in fact the rod is not nearly as precise as that. The rod, if I check with a caliper, is not exactly round. It's slightly oval. And this isn't surprising, because it's a seamed tube. A seamed tube is never going to be perfectly round. And if I put a caliper on here and I look at the diameter of the diameter nominally should be 100, it should be 1.3125. Here I've got 1.3325. If I rotate it, 1.320. Here I'm at 1.318. Here I'm at 1.316. And then it's going to start to go up again as I continue to rotate. So the tube is slightly oval. It's got a major axis and a minor axis. And that proved to be enough to prevent it from going into the clamp, no matter how hard I tried, when I had only a single bolt. So I had to go to this design where the 2 halves of the clamp come completely apart so that I could get the tube in here. So now let's hook this thing up and see how it looks.